Welcome to this lesson on convoluting filters on images. In this session, we'll explore how filters can be applied through convolution to modify or enhance digital images. You'll see how this process helps reveal details, smooth textures, or detect edges, and gain a better understanding of how image filtering works in digital image processing. In photography, a filter is an accessory that attaches to the camera lens to change how light enters the camera. Different filters can modify brightness, color, or reflections to enhance the final image. On the right, you can see a circular polarizing filter, which helps reduce glare and deepen color contrast, producing clearer and more vibrant photos. Here's an example showing how filters can change the appearance of an image. The photo on the left was taken without any filter, while the one on the right was captured using a circular polarizing filter. Notice how the second image appears clearer, with richer colors and reduced reflections. In photography, physical filters shape how light enters the camera. In digital image processing, we use digital filters to achieve similar effects through computation. The process of applying a filter to a digital image is called filter convolution. In this diagram, the large grid on the left is the source image, and the smaller 3x3 grid above it represents the digital filter. To perform convolution, we align the center of the filter with a pixel in the source image. The filter covers a small region of the image around that pixel. Each overlapping value in the filter and the image is multiplied, shown here by the times symbols, and all the results are then added together, as indicated by the plus symbol. The single number produced from this calculation becomes a new pixel in the output image on the right. The filter then moves across the image one pixel at a time, repeating this process until every position has been processed to create the full filtered image. Here, we'll walk through an example to understand how filter convolution works. On the left, the matrix represents the source image, and the empty grid on the right represents the output image. We'll apply a 3x3 filter to this image. First, we select a 3x3 region from the source image, shown here in green. This small section is the part of the image the filter will process. Next, we bring in the digital filter, shown in blue, and align it directly over the green region so each element of the filter corresponds to one pixel in that area. Now, we perform element-wise multiplication between the filter and the image values. These are shown by the multiplication symbols. After multiplying, we add all the results together, as indicated by the plus symbol, and then divide by the total number of filter elements, which is 9. The result of this calculation is 23, and that number becomes the new pixel value written into the output image on the right. Finally, the filter shifts one pixel at a time across the source image, repeating this process until every pixel in the output image is computed. That concludes our lesson on filter convolution. We've learned what filters are, how they're used in photography, and how convolution allows us to apply filters to digital images. You've also seen a step-by-step example showing how the convolution process works numerically. Take a moment to review what we covered, and think about how digital filters can be used to enhance or extract information from images. If you have any questions, feel free to ask, and we'll discuss them together in the next session.